Hi guys, in this lecture we'll discuss some of the problems based on the concept of sampling that have appeared in the recent GATE exam. Now, first of all, what you have to remember in sampling is that whenever we sample a signal, the copies of its spectrum are repeated at regular intervals of sampling frequency. Okay, so I'll explain this concept by the first problem. It says a band limited low pass signal of bandwidth 5 kilohertz, okay, which means this is a low pass signal, so it will exist between -5 and 5. When we talk about bandwidth, we only take the positive frequencies, that is 5 kilohertz. Now it says it is being reconstructed using the reconstruction filter HF, whose magnitude response is shown. Now suppose it is asking the sampling frequency. Suppose sampling frequency I assume as Fs. Now by sampling, what will happen? This spectrum will repeat after Fs. First one is original spectrum, then the next one will be the repeated copy, then again repetition. Similarly on the left hand side also. So this center would be at Fs, so this value will be Fs minus 5, this would be Fs plus 5. Now if you want to have perfect reconstruction, then what will be the condition for perfect reconstruction is the spectrum of output should be same as the spectrum of input. Okay, if both must have the same spectrum, that means the original spectrum must be filtered. Only you should filter the original spectrum and nothing else. Now filter filters the frequency between -8 and +8, and we want it should only filter up to -5 and 5. That is, this term from Fs minus 5 should not lie inside the filter. Or what I can say, Fs minus 5 should be greater than 8. What I mean to say is it will pass the frequency up to 8 kilohertz. But it should not pass any copy of the spectrum. It should only pass the original one for perfect reconstruction, and that is why this edge of the next spectrum should lie outside the filter range. So it will be 13. So the answer would be 13 kilohertz. Moving to the next one, it says the signal xt equal to sine 14,000 pi t. Now xt equal to sine 14,000 pi t. What is the frequency of this signal? 14,000 pi divided by 2 pi, that is 7 kilohertz. Okay. It is sampled at a rate of 9,000 samples per second, or we can say sampling frequency is 9 kilohertz. Now the sampled signal is input to an ideal low pass filter which passes frequencies up to 12 kilohertz. It is asking which frequencies will be passed. So again remember, output frequency will be the first one equal to the original one, okay, or you can say original and the negative, because whenever a sinusoid is involved, the spectrum of a sinusoidal signal involves a positive frequency and a negative frequency. That is why I am saying 7 and -7. What are the others? You have to add 9, 16 and 2. Then in the next case, you have to add 2 Fs, that is 9 into 2, 18, 18 plus 7, 25, 18 minus 7, 11. Then add 9 into 3. How much will be 27 plus 7, 34, 27 minus 7, 20. And it will go on increasing. But the filter can only pass up to 12 kilohertz. Which are the frequencies in 12 kilohertz? 7, 2, 11. So 2, 7 and 11, these three frequencies would be passed. Okay. So that is as simple as that. You just have to find the frequencies generated by sampling. So remember, F naught is frequency that is passed, Fs plus minus F naught, then Fs plus minus, 2Fs plus minus F naught, 3Fs plus minus F naught. That way you have to proceed. Then consider the signal cos 6 pi t plus sine 8 pi t. We need to find the Nyquist sampling rate for yt, which is x of 2t plus 5. Now if you substitute this, instead of t we write 2t plus 5, 12 pi t plus 30 pi sine 16 pi t plus 40 pi. A multiple of 2 pi will never affect a sinusoidal signal, so it will be like this. Okay. Now, the frequency of the first signal is 12 pi by 2 pi, that is 6. Frequency of second one, 16 pi by 2 pi, that is 8. What is the maximum frequency? Out of 6 and 8, maximum frequency is 8 Hz. So the Nyquist sampling rate is 2 times the maximum frequency, that is 16 Hz. So the answer would be C. Okay. Next one. It says a continuous time sinusoid of frequency 33 Hz is multiplied by a direct impulse train of 46 Hz. Then we pass the resulting signal through a low pass filter of cutoff frequency 23 Hz. Okay. So what are the frequencies at the output of sampler? Plus minus 33, then 46 plus minus 33, which is how much? It will be 79 and 13. Then 92 plus minus 33, how much? 95, 125, and the second one would be 59. But the filter only passes up to 23 Hz. Which is the frequency lying under 23 Hz? That is 13. So the answer would be 13 Hz. Okay. So you just have to draw the output frequencies and then check which frequencies lie inside the band given of the filter. Moving to the last problem, consider a continuous time signal defined as a sinc function convolved with a impulse train. We need to find the Nyquist sampling rate. Now if you want to go into the frequency domain, you need to find the Fourier transform of impulse train. You can very well directly remember. So you can remember it like this. When there is a impulse train, that is delta t minus nts, the Fourier transform is 1 upon ts summation n equal to minus infinity to infinity delta f minus n fs. Here ts is 10, which means fs is 0.1. So the Fourier transform of this impulse train would be how much? 0.1 summation f minus 0.1 n. Now what about this sinc function? We know a rectangle t by t, the Fourier transform is at sine pi ft divided by pi ft. If you take duality property at sine pi tt by pi tt, the Fourier transform, I am directly using the even function property of rectangle function, it will be this. Now compare. It has given us pi t by 2, which means capital T is half, and at is 1, which means a is 2. So what I can say is sine pi t by 2 divided by pi t by 2. The Fourier transform would be how much? 2 rectangle f into 2. Okay. That means the rectangular function has an amplitude 2 and it is existing between minus 1 by 4 to plus 1 by 4. Okay. Now if you see this impulse train has impulses at point 1, point 2, point 3 like that, it can only pass up to 0.25. Okay. So which impulses will be passed? Impulses that will be passed, impulse at 0 frequency, 0.1 frequency, 0.2. Okay. Because when n is 0, it is an impulse at origin. Then n is 1, it is impulse at 0.1, n is 2, impulse at 0.2. What is happening actually is, in time domain, both the functions are being convolved, which means in frequency domain, both will be multiplied. Now one function, this impulse function actually is a impulse train like this. Regular impulses at gap of 0.1. And the other function is a rectangular function which only passes frequencies till 0.25. So what I mean to say, when both will be multiplied, only the frequencies up to 0.2 will be passed, because 0.3 will lie outside the range. So 3 impulses will be passed, 0, 0.1 and 0.2. Which means what is the maximum frequency? 0.2. So what is the sampling frequency? 0.4. Okay. So that will be the answer. The answer would be 0.4, that is the Nyquist sampling rate. Is it fine? So that is what I have used the Fourier transform while using the concept of sampling. So always remember that you have to have a good grip over the concepts of Fourier transform if you want to crack the problem based on sampling. So this will be all from this lecture, and I hope you have gotten a gist of the kind of problems that are asked in GATE. Thank you.